Hey class, Absolute 5 here, and today we're going to talk about the greatest common factor. We learned how to multiply polynomials. Now we will deal with the opposite process of multiplying factors. So what is that? Let's see, what does that mean? Factoring allows us to write a sum as a product. Multiplying when we normally multiply, we would distribute the 5 into both those terms. So 5 times 5 times x squared plus 3, it'd be 5x squared plus 15. And 2x times x would be 2x squared. 2x times negative 7 would be negative 14. And then we now factoring is the reverse of that. So then instead of giving towards the distributing the numbers, you're pulling things out by factoring it out. So I notice there's a 5 in both these terms, so I could pull out the 5. And I notice 2 can go into both the numbers, but also each term has an x, so I can also pull out an x. All right, let's go down. Finding the greatest common factor, a list of integers. So how to do this is that we will do it term by term. First we'll do the numbers, then the variables, and then together. Step 1, write each number as a product of prime numbers. Step 2, identify the common prime factors. The product of all common prime factors found in step 2 is the GCF. If there are no common prime factors, then the GCF is 1. So let's see here. So find the GCF of each list of numbers. So we're going to find the greatest number that can divide into both the two numbers. So let's think. We could use 2 for the first one, 28 and 40. Is that the greatest common factor? Well, I could do a little bit higher. We could use 4. I believe the GCF for this one is 4. Why is it 4? Because if you were to write out the multiples that divide into 28 and 40, it would be 4. Because look, if we use, let's say, what goes into 28? We got 7. But the problem with 7 is that 7 doesn't divide into 40. Now if I use, I don't know, like 6, no, that's 6. If I use 20 for 40, 20 doesn't go into 28. You see? So the GCF for the first one, it's 4. The GCF for the second one, whoop, that's not enough. So you have to write it as a product of prime numbers. Oh, wait, no, let me go back. I did the first one wrong, sorry. Write it as a product of prime numbers. So 28 would be 4 times 7, but you can break that up to 2 times 2 times 7. And 40 can be 44 times 10, which can be broken up to 2 times 2 times 2 times 5. So in this case, the GCF, again, is 4, since these are the greatest common factors. That makes more sense, because I literally ignored what it was saying here. So you have to write as a product of prime numbers. So then 55 would be 11 times 5. And 21 would be 3 times 7. They have nothing in common. So in this case, the GCF is 1. So let's do 15, 18, and 66. So we know 3 times 5 is 15. 6 times 3 is 18, but we can break up the 6 to become 2 times 3 times 3. And then 66 can be broken up to 22 times 3, which can be broken up to 3 times, well, not 3, 2 times 3 times 11. So there's a 3 in all the terms. So in this case, the GCF for C would be 3. Okay? So as you see, you can break up things and you can pick out which one is the GCF of the point of the GCF is to help you factor. That's the whole point of the GCF. This is just with integers, mind you. Now let's do the GCF of terms, which is our variables. The GCF of a list of common variables raised to powers is the variable raised to the smallest exponent in the list. Let me repeat that. The GCF, the greatest common factor, of a list of common variables raised to powers is the variable raised to the smallest exponent in the list. So in this case, we can't write it as a product of primes, but think of it this way. Think of it as the highest amount the variables can give is the GCF. So in this case, we know the GCF here. Let me just erase that. The GCF in this case is going to be what? X to the third. Why? Because that's the most x to the third can actually give. I'm not looking at x to the 7. I'm not looking at x to the 5th because we know they can give more than that, but x to the third cannot. So knowing this logic, it's the smallest, so therefore the GCF will be, for the next example, be what? Just y, because y can't give any more than y. Why? Because why not? So therefore you know that the next one for C is y to the 4th. The GCF would be y to the 4th. And then the GCF for the last one is just going to be x. Make sense? Excuse me. Going down, the GCF of a list of terms is the product of the GCF numerical coefficients and the GCF of the variable factor. So basically now, if we go back all the way back to the beginning, for this first one, it literally took the integers and the variables at once, which is the concept of factoring. So now you understand how that works. Let's go now down to this one. So what would the GCF be for the first one? Well, let's see, can we break it up into product of primes? So 2 times 10 would be 2 times 2 times 5, but then we have, so we're trying to find the GCF of 20 and x squared, y squared. So x squared looks like the highest and y squared looks like the highest, but what's the most can x give? X can only give x, and y squared is the highest in the first term, so it'll be y squared. That's the most when it comes to the variables. Now we look at 6, it's 2 times 3. So therefore, the GCF would be 2 times 3. This would be x, and this would be y squared. So we have a y squared here for the GCF, and the only thing we have in common will be 2. So then the GCF would be 2xy squared as your GCF, or your greatest common factor. Okay? These are the things that they have in common. We'll do one more. We'll do a triple. Wow, that's a lot. So we have 8x, 6x squared, and 10x to the third. So as far as variables, we already know the most a variable can be given will be just x. Why? Because 8x can only give x as the most it can actually give. And now let's break 8 up into a product of prime numbers. So it's 2 times 4. Just leave this as x. This would be 2 times 3x, and this would be 2 times 5x. Can I break down the top one further? Yes, I can. So it would be 2 times 2 times 2x, 2 times 3x, and 2 times 5x. So I've circled all the numbers here, and I circle all the variables. So the GCF, the greatest common factor, would be 2x. That's the most you can factor out in all the terms, okay? So yeah, I think that sounds good. Here's an example for you guys to do for homework. Be sure to leave your answer down in the comment section below. And, well, that's the lesson for you guys. I hope you enjoyed it. Be sure to like, share, and subscribe to my channel. Mash that bell button for more content, and I'll see you guys next time with another video. This has been Absolute 5. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, don't hate, calculate.